and now they can use the tools in the website to activate this support feature in software in their target. Now they can give commands to the computers running the software in the industrial control system. Hello everyone, and welcome to Waterfall's Industrial Security Institute. I'm Andrew Ginter with Waterfall Security Solutions, and in this video series we are working our way through the top 20 cyber attacks on industrial control systems. In this series, we're using the top 20 attacks to compare the strength of two different security postures at a hypothetical water treatment plant. The one posture is classic 2013 vintage software-based security advice. Stuff like antivirus, layers of firewalls, encryption, security updates, and so on. The other security posture is that same vintage 2013 state-of-the-practice security posture, augmented with one thing. We replaced the IT/OT firewall with a unidirectional security gateway. The gateway is the only connection between the industrial network and the enterprise network. And the gateway is physically able to send information in only one direction, from the industrial network out to the enterprise. The metric that we're using to compare the performance of these two security postures is reliably defeats. Does each of the security postures reliably defeat each of the 20 attacks? So let's get started. Today's attack is a vendor backdoor. The attack scenario: a vendor has built a software product. It could be a control system product, it could be a network driver, it could be a piece of the operating system, it can be any software product that we're using in the industrial control system. And the vendor has built into this product a little bit of technology that calls the vendor's website, let's say once a week, and asks the vendor's website, is there a new version of the software available? And if a new version is available, that software brings up a dialog for the user on the computer and says, hey, there's a new version of the software available. It does not automatically install the software. It just alerts the user that there's a new version available. Unknown to the users, maybe even unknown to the vendor, the software development team has decided to extend that mechanism a little bit and put what amounts to a backdoor in the product. When the product checks once a week to see if there's a new version, the website can be configured to send a signal back, not just no, there's no version, but a signal coming back that says, hey, maintain a connection to the website. Keep the connection open. And then over the course of time, can use that connection to send commands to the software to diagnose problems, to fix problems before the customer even knows there are problems, to help the customer walk through a diagnostic process. For any number of benign reasons, this could have been inserted into the product, but it's in there. Here's the scenario. The bad guys, let's say hacktivists. These are not people who are extremely sophisticated hackers. These are people who have a degree of cyber sophistication, and they have it in for a number of industrial sites. These people are looking around at industrial control system products, trying to find out what nasties can they discover. They download a version of this software that they know is being used at certain sites that they have it in for, that they want to impair somehow, and they discover the back door. They look at the instructions, they look at the code, and they figure this out. Now they do their homework. They figure out who's working at the vendor. They launch a spear phishing email campaign against the vendor, and they steal the website password. They log into the website, and now they can use the tools in the website to activate this support feature in software in their target. Now they can give commands to the computers running the software in the industrial control system. What are the consequences of this attack? Well, it really depends on what commands are issued. If these are important computers and ransomware is planted there, vanilla ransomware downloaded from the internet, or so that the hacktivists can deflect blame for this attack to the ransomware organized criminals, Or, maybe just a command to erase the hard drive and impair operations. These are very simple attacks, and the simplest consequence is generally shutting down the physical process for a period of time until hard drives can be restored and an investigation can figure out how did this happen and how do we prevent it from happening again. So, compare this attack to the two security postures. The 2013 security posture, is antivirus going to detect this attack? Well, no. This is not malware. This is the product. It's doing what the product does. There's no virus signature that was triggered by using this product on the operating system. Is intrusion detection going to detect it? Well, it might detect that a connection that happens once a week was not closed, that it was left open. How suspicious is this? Not terribly. You might imagine that it would detect commands coming in, but it's never seen these commands before. There's no signatures for these commands, and they're most likely over an encrypted connection. How suspicious is this? It might twig someone at the Security Operations Center to do an investigation. It might not. They might have bigger fish to fry. They might have real ransomware kicking around somewhere on the enterprise network that they're investigating. So what we're saying is that none of these security mechanisms in the vintage 2013 state-of-the-practice security posture, software-based security posture, is going to detect this attack reliably. The intrusion detection might have detected it. It might not detect it. So let's look now at the security posture that is augmented by a unidirectional security gateway. What happens with this software in that scenario? Well, the software tries to connect to the internet once a week to see if there's a new version, and it fails because the gateway can send information out to the enterprise. Nothing can get back. But the gateway makes copies of systems, makes copies of servers. It might make a copy of a historian database or an OPC server. The gateway is not a firewall. It's not a one-way firewall. It's not a router. The gateway cannot forward network packets from the industrial network out to the enterprise network or out to the internet. And so the software's attempt to connect out to the internet is going to fail. And even if somehow it figured out how to make it succeed, none of the commands that the attackers are going to send back from that website are going to get back into the industrial network. They can't. The unidirectional gateway software makes copies of servers, but the hardware is physically able to send information in only one direction. It's not physically possible to send information back. So the 2013 security posture augmented by the unidirectional gateway does reliably defeat this class of attack. And let me add, I'm regularly asked if these 20 attacks have been observed in the wild. To my knowledge, this one, as phrased, has not. What we do see on a regular basis is backdoors of some sort left in products that are used on industrial networks. There have been numerous reports of backdoors of hard-coded passwords, administrative passwords in firewalls. There have been numerous reports of hard-coded passwords in other kinds of products, industrial products and conventional products that are used on industrial networks. But this sort of more sophisticated remote control capacity has not been reported yet. So looking now, we can see our scorecard. The unidirectional security posture is significantly better at defeating attacks than the 2013 vintage security posture that we've postulated for this hypothetical water treatment plant. That's what I had for you this time. Don't forget that if you're interested in much more detail, I do have a white paper on this topic available on the Waterfall website. Go to the resources menu and look under white papers. This has been Waterfall's Industrial Security Institute. Thank you for joining us.